Hi everyone, this is Vincent Nyangaresi, and I'm doing a presentation on a paper titled Dynamic Ephemeral and Session Key Generation Protocol for Next Generation Smart Grids. So my other co-authors are Zaid, Mustafa, Wahab, and Iman quiz. So the smart grid networks provide some two-way communication between the smart meter and the utility service provider, which is basically the power generation companies. So this two-way communication enables the USPs to analyze the real data coming from the consumers and also provide some dynamic adjustments to the power generation and transmission based on the received reports. However, we note that the periodical transmission of these consumption reports from the smart meters to the USPs over the public channels expose the exchange messages to a number of attacks such as eavesdropping and modification. Therefore, the power adjustments executed by the USP may not be occasioned by the legitimate consumers, but by some malicious entities sitting in between the smart meters and the utility service providers. Therefore, a number of schemes have been presented in literature based on technologies such as identity, elliptic curve cryptography, point multiplication, blockchain, the public infrastructure, and also bilinear maps. However, we know that schemes based on identity require that the communicating entities exchange their real names and identities during the verification process, which can potentially lead to the leakage of the exchanged identities. And with regard to the schemes based on elliptic curve cryptography point multiplication, the problem is that they require high computational overheads, which is not ideal for resource-constrained smart grid elements such as the smart gas meters. The same applies to the blockchain, but in addition to that, blockchain is also known to have issues to do with high storage complexities. The schemes based on the public infrastructure have issues with the certificate storage and also the heavy signaling that is involved during these certificate generation and distribution. And lastly, the schemes based on bilinear maps have high computational complexity, which is not ideal for the smart grid network components. And in addition, majority of these protocols are vulnerable to a number of attacks such as traceability, impersonation, and packet replays. So to prevent some of these issues, transient security tokens are employed in this paper to dynamically generate the session keys to protect the exchanged power consumption reports. So all the smart grid network entities communicate using their pseudonyms to uphold their anonymity and traceability. The security analysis is executed to show that this protocol has superior security features compared with its peers. So in terms of performance, it is shown that the proposed protocol had the least bandwidth requirements and also the lowest execution times. So onto the system model. So the network entities involved in the proposed protocol included the registration authority, the utility service provider, the gateway node, and then the use of the smart meter. So in this arrangement, the smart meters submitted some periodical reports to the USPs based on the measurements that they carry out at the consumer premises. So the gateway nodes forwarded the packets from the smart meter because we know that the smart meters have lower computation complexity and therefore they're not able to transmit data to larger distances. So on the other hand, the utility service provider is the one that adjusted the power transmission as well as consumption based on the received reports. So the registration authority is required to register all these communicating entities and also assign them the security parameters that they do use during the authentication and key agreement phase. So this proposed protocol is executed in two major phases. We had the registration phase and the authentication and key agreement phase. So during this registration phase, the process begins by having the RA derives a master key and also register all the communicating entities, which include the smart meters, the gateway node, as well as the USPs. So in step one, the RA generates some shared key and a smart meter identity before deriving the smart meter pseudonyms. And then next, it uses the parameters that were assigned during the previous step to compute or to derive some transient security token, TTS. And we realize that this transient token generation incorporates some current timestamps, which is critical for the prevention of replay attacks. And then in step two, we also have the registration of the utility service provider before it can begin to send and receive end packets from the smart meter. So the process begins by having the USP generate some a pseudonym, which it sends to the registration authority together with its registration request. So in step three, upon receiving this message, the RA generates some secret key followed by the derivation of some pseudo identity for this particular USP. Then it also computes a transient token for this particular USP before it generates some second parameter S that it uses to derive two additional security tokens as shown in step 3. So then afterwards, the RA sends this registration response to the USP through some secure channels. So upon receiving this message from the RA, the USP randomly selects some redundant login parameters, which it uses to derive the 6 parameters shown in step 4. And then finally, it buffers the computed parameters in its memory for subsequent authentication. So in step 5, upon successful registration, the array computes some 3 additional parameters before it can construct the message authentication, that is MS1, that is then sent to the gateway node. So the gateway node, these parameters are buffered for the next or for the subsequent authentication and key agreement phase. Right now, we move on to the authentication and key agreement phase, which is triggered whenever the USP wants to access some data from the remote smart meter. And we can see that the process begins by having the USP utilize some of the parameters that were assigned during the registration phase to compute the 5 security tokens shown in step 1 before one of these computed parameters is validated. So upon successful validation of this parameter Q, then it proceeds to derive other security parameters shown in step 1 before composing the message authentication shown in the last paragraph of step 1. So on receiving this message from the USP, the gateway node determines the current timestamp, then validates the freshness of the received message, which then compares to some set threshold. And this set threshold basically represented the maximum permitted transmission delay. And this check is very important for the protection of this communication process against replay attacks. So if this message 2 passes the freshness check, then the gateway node derives the security parameters shown in step 2 before composing message 3 that is then sent to the smart meter over some secure channels. So upon receiving this message, the same process repeats itself by having the message checked against some set threshold timestamp as shown in step 3 before the smart meter can derive the parameters shown in step 3. So next, one of the computed parameters is validated, and if this condition is false, then the authentication session is terminated. However, if this verification is successful, then the smart meter is successfully authenticated by the gateway node. So next, the smart meter generates some random nonce and returns the current timestamp, which are then used to derive the four parameters shown in step 4 before constructing a message MS4 that is then sent at the USB through some public channels. So upon receiving this message, the USB returns the current timestamp, also checks the freshness check, executes some freshness checks of the received message, and upon successful verification of this message, it proceeds to compute the security parameters shown in step 5. So upon successful mutual authentication among the gateway node, the USB as well as the smart meter, then they proceed to derive some session key, which is then set for the protection of the exchanged packets. So under the security evaluation, so we formulated a number of theorems that are then proved to show that the proposed protocol offered some security, some superior security features compared with its related schemes. So we start off with the denial of service attacks, where we note that during the authentication and key agreement procedures, the USP derives a number of parameters through the confirmation of parameter Q. So it's only upon the successful verification of parameter Q that the process or the algorithm proceeds to other stages. So we also make use of the authentication message request, MSS2, that is transmitted towards the gateway node to validate the received messages. So devoid of this successful local verification, the authentication request cannot be sent over to the gateway node. And again, the incorporation of timestamps and random nonce means that the computed authentication parameters are stochastic and hence cannot be easily determined by an adversary for possible session hijacking and denial of service attacks. So with regard to anonymity and traceability, so in the proposed protocol, we make use of timestamps that are incorporated in each of these exchanged messages. So we also make use of the random ones during the authentication and key agreement phase. And therefore, it means that the exchanged messages are session specific and therefore cannot be determined easily by the attacker and then deployed to track the gateway node or the smart meter during the communication process. So with regard to the replay attacks, so in the proposed product, we have seen that timestamps are incorporated, and upon reception of each of these messages, there is the determination of the current timestamp that is then used to determine the transmission delay for each of these received messages, which again is checked against some set threshold. So it's only about upon successful freshness checks that the protocol can proceed to the other stages. Therefore, it means that an attacker is unable to intercept, modify, and forward the transmitted messages because of the little transmission delays that are permitted. So with regard to forward key secrecy, so you've seen that the derivation of the session key involves a number of parameters that are specific to the particular smart meters, gateway node, or the USPs. And also there's also the incorporation of timestamps and some random nonce. And therefore it means that it will be difficult for the attacker who has dropped the current session key to use it to derive the session key to be used for the subsequent authentication. So in this table, we compare the security features of the proposed protocol against other related schemes. And you can see that the proposed scheme offers more security features when compared to the other schemes developed in reference 23, 35, 4, and 45. So in terms of the bandwidth requirements, again, you can see that the proposed protocol had the least bandwidth requirements in terms of the exchanged bytes during the authentication and key agreement phase. And then in terms of the execution times, You also see that the scheme proposed in reference 4 had the largest execution time of 17.306 milliseconds, while the proposed scheme had the lowest execution times. So in conclusion, we have seen that the data that is transmitted over the smart grid networks is vulnerable to a number of attacks that can compromise the security as well as the privacy of the exchanged power consumption reports. Therefore, a number of schemes have been developed to address these issues. But again, you have seen that these schemes fail to offer the required level of security and privacy at lower computation as well as communication costs. So you developed a protocol that has been shown to have superior security features at low bandwidth requirements and also execution time. So this marks the end of my presentation. Thanks for listening to me. So if there is any question, feel most welcome. Thank you.